start. Welcome everyone. So this is our 34th live stream geometry, and today I chose problems from the Rioplatenese Math Olympiad. So it's a contest in Argentina, and a bunch of countries from South America all participate in it. It's a contest for high schoolers. And Rioplatenese, it's actually a certain variety of Spanish that I believe is mostly spoken in Argentina. So they named the contest after the type of Spanish that they speak in Argentina. And there's 3 different levels of problems, level 1, level 2, level 3. And I chose mostly the level 3 problems for today. So we'll see how many we get through. And with that, I will share my screen. Hold on just a second. All right, so here's the first problem. So I chose GeoGebra Classic today. So usually I do, GeoGebra has like 2 different setups, but this one I've never done before and I think it might work better. So I'm gonna try it. So we have a triangle ABC with AB is less than AC and circumcircle omega. All right, so there we go. M and N are the midpoints of AC and AB. So I will rename those. And I feel like it's easier to rename points in this form GeoGebra. So N is the midpoint of AB and M is the midpoint of AC. And G is the centroid. So the centroid is the intersection of the medians. So that would be the intersection of CN and BM. All right. And P is the foot of the perpendicular from A to BC. Yeah, for some reason, Zoom is making me admit each person one by one into the meeting instead of, hey, Arjun. So thanks everyone for joining, Arjun, Hakan. Yeah, for some reason, Zoom is making me admit each individual person in instead of just letting everybody join, which is weird. All right. So I will hide most of the altitude and I will draw AP. So Q is the intersection of GP and omega. So there's actually a name for this point, I3435, if you guys remember him. This point is called like the Y point, and it has like a lot of special properties. But I forgot what they all are. But I did a video of one problem that used this point, the point Q right here. All right, so QM intersects this. So we want to see where QM and QN intersect the circle. And M1 and N1. Okay. So this is M1 and this is N1. And K is the intersection of BM1 and CN1. And we want to show that PG and K are collinear. It's interesting. All right. Let me hide a couple things here, and then I will check the chat. right. But yeah, this point Q, I forgot all the properties of it, but I know it has like a lot of special properties. So I'm gonna rename this point K as in the problem. And I will move a couple things around. So it's Q, P, and now I will check the chat. Yeah, I don't remember what was in that paper, but I can give you guys a link to it. I'll post a link to it on Discord. Oh, I didn't have any real observations yet. I just know that Q, so G is a centroid and GP meets the circle at Q. And I know the point Q has some special properties, but I just don't remember what they are. I wonder if N1, M1 is parallel to BC. It looks like it, doesn't it?
Yeah, I think it was a ISL problem that Q and M is tangent to ABC, which implies N1, M1 is parallel to BC.
So did you say something's tangent? So Q N1 is tangent to something?
No, circumcircle of Q and M is tangent to circumcircle of ABC.
Ah, okay. So that's that special property.
It was to ISL 2011 G4.
Oh, it was an IMO shortlist problem? Or what contest did you say it was?
2011 G4.
2011 G4. All right. Interesting. So from that, we kind of know N1, M1 is parallel to BC. And this feels like maybe Pascal's theorem. So let's see. Are NK and M collinear? I think they might be. Yeah. And I think that's Pascal's theorem, right? NK and M are collinear by Pascal's.
Yeah.
Okay. And N1, M1 is parallel. Yeah, I don't even know if we need that N1, M1 is parallel, just that NK and M are collinear. Actually, I don't even think Q needs to be a special point because we can always just apply Pascal's, right? And K is always going to lie on NM. Oh, but we'd have to know that they're tangent. Okay. So we want to show PG and K are collinear. Let's see. Phantom point. Could be. Maybe we could use Pascal's again. So there's a couple of ideas I have. We could try using Pascal's again, although I'm not sure how great that would work. We could try Desargues, or we could try just using ratios. There's a couple of different ideas. Let's see.
From where are you reading the messages other than this Zoom chat?
Oh, I'm just reading them from the Zoom chat.
Actually, I can't see them.
Oh, you can't see them in the Zoom chat? I don't think I'm able to share the, I don't know if there's a way to share the Zoom chat, but yeah, some people send me messages privately, like, so like when I mentioned phantom points, someone sent me like a private message with that. But yeah, but yeah, I encouraged, yeah, I encourage you to send the messages to everyone if possible, just so everyone can see it. But Arjun, you're not able to see anything in the chat, even like the public messages?
I can see two messages. One is which I have sent, and one is sent by Hakan. I think he sent privately.
Okay, you can see Hakan's. All right. All right. Let's see. So where can we go from here? Can we find the ratio NK over KM? It looks like KB equals KC. It does kind of look like that. Is that true? Let's see. That certainly looks true. I'll just check.
What was your conjecture?
That KB equals KC. Yeah, interesting. Let's see if there's a way to prove that.
I think it will follow by homothety.
Oh yeah.
Oh, sorry. Not for this K. I think if we define K, if we redefine K as the intersection of PG with NN.
Yeah, maybe it's best to do it that way. So let K prime be PQ intersect MN, and then show K prime lies on each of those lines. That is one way to do it. Yeah, maybe that's the best way to do it.
Like in this case, how we have defined K, it is clear that KB equal KC because like B N1 M1C is isosceles trapezoid.
Oh yeah, no, yeah, it is obvious. Yeah, because that's an isosceles trapezoid. Good point. I didn't see that. All right.
Yeah, I think now it is not too hard.
Okay.
Yeah, I think we are just done. Like we just need to show that like if K is a point on like we just need to show if PG intersect NM at K prime, then K prime B is equal to K prime C, which is like not too hard if we like let like if we extend AG to meet the midpoint of BC.
Okay, so AG by Chevas meets intersects at the midpoint of BC, right? Is what you're saying, right?
Yeah. And after this, we just need to show like mark this point as D, say.
All right.
And just connect P to K. Like we know we have defined like they are collinear. We just need to show that KD is perpendicular to BC.
Okay. So I'll call this K prime.
Yeah. Indeed, I think what one can do is that redefine K prime as the projection of D onto NM.
Oh, that might be an even easier way to do it. Okay.
Yeah, so that then it is clear by like ratios that AG by GD is equal to AP by KD. So by similar triangles, we must have that P, G, and K are collinear.
All right, hold on just 1 second. I'm going to write that up in just a second once I finish fixing the diagram. So let K prime be the perpendicular from D to MN, is what you're saying, right?
So from D to MN.
All right. And so I'm going to rename it. We want to show that so first we would have to show that N1, K prime, and C are collinear. Is that obvious?
No. But basically, we have proved that like BM1, CN1, and MN intersect on like they intersect on MN, and we know that that point lies on the perpendicular bisector of BC. So we just need to show that if we define K prime as the intersection of perpendicular bisector of BC with MN, then PJ K prime are collinear. So we
Okay.
just need now we can just know that this like K prime D by AP is equal to half is equal to AG by GD.
AG over GD. Okay. Yeah. No, I got it. All right. I'm going to write it up. Just a second. Yeah. So basically, yeah, AG over GD is equal to AP over K prime D. So that solves it. All right. I'm going to write it up. Can everyone see what Arjun is writing? Is everyone able to see that or just me? But Arjun, I see. Okay, everyone can see it. All right, Arjun, I'm going to type it up using the text editor just to make it look nicer. But I like your idea. It's a really nice idea. So okay, so hold on a sec. So we know that CN1 and BM1 intersect on MN. Do we know that K prime is where they intersect? Like, what if they intersected here or here?
No, basically we know they intersect.
Oh, it's by
that
symmetry.
intersection.
Yeah.
No, not by symmetry. We know that the intersection point lies on the perpendicular bisector of BC.
Yeah, like it lies on the perpendicular bisector of BC, and it also lies on the perpendicular bisector of MN. So, all right. Okay, so I'm going to, let me see if there's a way to, hold on just a second. I'm gonna.
Actually, it doesn't lie on perpendicular bisector of MN. I think you said.
Or K prime lies on the perpendicular bisector of BC, and it also lies on MN. Let me see if there's a way. I'm trying to erase what Arjun wrote just so I could type it up again.
I'm erasing it. I'm erasing it.
All right.
Like I've written on the Zoom thing, so it cannot be erased by GeoGebra.
All right, thanks, Arjun. So I'm going to delete this circle just because I don't think we need it for this problem, but it's probably useful in that IMO problem that you mentioned. Okay, so
actually, one easy way to see that, that dk prime, like basically k prime b is equal to, or basically k prime b is perpendicular to BC is by looking at a homothety at G with scale factor minus half. It will send B to M, C to N, A to D, and P to a point on Mn such that DP prime is perpendicular to NM because AP is perpendicular to BC. So that is just a very fast way to see.
okay, hold on. I'm just going to write it up this way to tell you what I'm going to. I'm going to let K prime be the intersection of BM1 and N1. So here's how I'm going to write it up. All right, so that's the first step. And then by Pascal's theorem, N, K prime, and M are collinear. And then, oh yeah, actually, I think we do need that the circles are tangent, right? Because we want to show that N1, M1 is parallel.
Yeah, we need that.
Okay, so that comes from the IMO problem.
Actually,
Is there another way to see it?
Actually, one short way to prove the IMO problem is that by homothety, you can prove that PG passes through a point A prime such that AA prime is parallel to BC. And then you can apply dual of Desargues-Nudison's theorem, DDIT.
Okay. So for now, I'll just say by the, let me just, write out the IMO problem for now. So what year is that IMO problem?
ISL 2011 G4.
G4 or G2?
G4 4.
Okay. All right. So, and then by homothency at Q and M is parallel to N1, M1.
I've also typed my solution in the chat.
All right, thanks. And then okay, so BN1 M1 C is an isosceles trapezoid. So I'll read it once I finish typing this up. So but that means that KD prime is perpendicular to BC by symmetry. And then once we know that, we have AG over GD is 2, which is AP over K prime B.
Actually, K is already defined in the problem, so you need not define K prime.
Oh yeah, yeah. I didn't need to call it K prime. I could just call it K everywhere. We didn't need that. You're right.
And you can just argue that the homothency which sends ABC to DMN will send P to K, and we are done.
Oh, so that's like a faster way. So the homothency that sends ABC to DMN, it has center G. Yeah, I guess that's like the same thing as showing that AG over GD is 2, which is AP over, like it's really, I mean, I guess you could probably prove the property of the homothency using that. I'm just gonna write it out. So, all right. So I see, I think it was Daniel from Iran just joined us. So thanks for joining, Daniel. So let me change all my K primes to Ks. Oops. Make that a K. And then is equal to AP, AP over KD. And that means that K, G, and P are collinear. And that solves it. Hold on just a sec. But we still need this IMO shortlist problem, right? So there's no way around using the IMO shortlist, right?
I didn't get you. Could you repeat?
Oh, you still have to use this IMO shortlist, right? There's no.
Yeah.
Okay. Let's see if we can. So I think you said there was a way to prove it using Desargues.
No, but for that you need to know that let the line QP let this line QPG cut ABC again at T.
Okay. So cut it at like a point here, and then
Yeah. Like number this point, just anything. Mark this point.
oh, I think
Then like AE is parallel
to
particular
BC.
BAEC is a isosceles trapezoid. This
Okay.
again comes by homotheity at a G.
Okay.
Uh, and then by Desargues involution theorem, like
Ah.
look.
So yeah, that's it. It's this argsin. It's the I call it the isogonal line lemma, but yeah, it's this. Well, I guess the isogonal line lemma is a special case, but yeah. So it's
Yeah, yeah.
you have to use yeah, the isogonal line lemma. So I'll just write that right here. I also did a video on it. Let's see. So yeah. So yeah, this video on my channel has the proof of that. I'm pretty sure. All right.
Of Desargues involution theorem.
So I have another video on Desargues, or a special case of Desargues involution theorem, so the isogonal line lemma. But then I have another video where I apply that and I show that property you mentioned. So yeah, I'll just refer my viewers to this problem for now. But thanks for the solution. It was really nice. So let's move on to the next problem. All right, so we have
How do you pick the problems?
I go on, so there's this nice website. So I'll show, it's imogeometry.blogspot.com. So this website was created by this guy Parmenides from Greece, and it has like every contest. And I just pick ones that I find are interesting and where I think the problems look nice, and that's how I find them. So
Okay.
yeah, like any problem, any contest, you can click on it. So this would be like Taiwan's Math Olympiads, and he has like all the geometry problems since the beginning of it. And if you click the link, you can takes you to AOPS, which is really cool. So that's mainly how I come up with the problems. But so yeah, it's a really nice website. So I'll post it in the chat. Hold on just a sec. All right, so here's the next problem. We have a triangle with a circumcircle omega, and then we draw the AX circle. So, all right, let me draw rays AB and AC. And so usually I like drawing the X circle using the in-center X-center lemma. That's usually my favorite way to draw it. Let's see. Where's the angle bisector? Here we go. So let me draw the in circle, and then I'll also draw the X circle. So that's the in circle, and then for the X circle, oh, whoops, click the wrong thing. Let me close out of this. Oops. All right, so yeah, I'm gonna wanna move this up a little bit. Maybe make it something like this, just to make more room. And this should be the, I'm sorry, this point here is the X center. So yeah, I'm gonna have to rename a couple things. There we go. Okay, so actually let me hide that. Okay, so it's tangent to BC at D. So this should be, whoops, this should be D. So I'll just rename it as D. And I'll call this, I don't know. I'll call this K, just because I don't have a better letter. So it's tangent to AC at E, and it's tangent to AB at F. And M is the midpoint of arc ABC. Let's see, I could just do it this way.
You have already constructed it. It is D1.
No, it's, I think M is this point.
Oh, yeah.
That's all right. Then MD intersects the circle again at G. So this point is G, and AG intersects EF at H. And we want to show that HD is perpendicular to EF. All right, I'm going to make it look nicer. Don't worry. Okay, so we want to show HD is perpendicular to EF. It's probably worth, let's see, I'll just move this down a little bit. So it's probably worth drawing this point too. All right. There we go. How is G defined? I think MD and G are collinear, right? So yeah, let me rename this. I'll just call it L. And how did we define H? AG, oh, AG cuts EF at H. All right, and then I'm gonna hide this line, whoops. All right, I think that looks good. So we want to show HD is perpendicular to EF. Yeah, let me draw the center, the circumcenter of ABC. So whoops. Yeah, sorry, that's the wrong thing. We want O to be the center of the circle. What's the circle through A, B, and C called? C. Okay. What is this point N? You see a point n at, oh, n equals O. I'm going to delete that. All right. So I will close this out. This makes it look like I can move O though. Yeah, I wonder why O is in blue and not gray. That's interesting. So obviously BJ is equal to DC by the IM lemma. All right. We've got a lot of people today. Ali Hoisinov just joined us. Oops, sorry. All right, how do we show HD is perpendicular to EF? So yeah, it looks like a complicated problem, but it's really not. You just have, so MB meets the circle at G, and AG meets EF at H. So yeah, I feel like it's not as complicated of a configuration, maybe as the diagram makes it look like. Let's see. Can I draw DK and IJ? Yes. So DK is parallel to IJ. They're both perpendicular to BC. Maybe it's worth also drawing ML. I'm not sure. ML passes through O, of course. Oops. So yeah, can we use the fact that BJ equals CB? This looks tricky. ADGK is cyclic by an angle chase. Okay. AGDK. Is DH tangent to it? That's just a guess. I'm not sure if that's true. Do we know anything about G? I'm not sure. Maybe G has some special properties, but okay. Now that line.
How exactly is ADGK cyclic?
Yeah, Hakan says that by an angle chase, you can show ADGK as cyclic. So I haven't done the angle chase yet, but I believe him. Because angle, let's see, angle ADK, we'd want to show it's, let's see. Yeah, okay, angle MGA is equal to angle ALM is equal to angle AKD. So yeah, okay, so that proves it. This DGA is DKA. Okay. All right. Let's see who we have.
Maybe we can use GM is the angle bisector. Let GB and GC intersect the circle ADGK.
Yeah, so yeah, that's an angle bisector. So yeah, I kind of like that.
And LGM is 90 degree.
So we have like a harmonic bundle
Yeah,
basically.
if we let LG cut BC at some point.
Okay, so this is a right angle.
Yeah, if
And
we let BC cut LG, we will have a harmonic bundle.
all right, so yeah, I wonder if EF passes through that point. Yeah, these points look collinear, and I think it's probably not hard to prove it. Maybe like using polar stuff.
It's probably because 3 lines intersect. Can you delete GC and GB? They are useless, probably.
Oh yeah, I'll go delete them.
I think proving the concur is direct by that famous Sega-Menelaus confi and this harmonic thing we just know.
Okay, hold on just a second. So, okay, so I'm gonna first just hide a couple things here. I think it was L, G, and N, right? Yeah. So basically, GA bisects. No, I'm sorry. GM bisects angle BGC, and angle DGN is right. So we have a harmonic. So BDCN is harmonic, and then from that, I think we could probably prove that these three concur.
Yeah, I think it's direct. Like if we mark EF cap BC as N prime, then we can, like we know that BC D N prime is equal to -1 because because of that Sega-Menelaus confi AD BE and CF concur by just by Seva's theorem.
Okay.
Michael, I could prove that BC, LG, and EF is concur. Just use normal thing. Okay.
Right. Okay.
Okay. So you have already proved it.
Yeah, we have, but you can continue. I just.
Okay. So if we have the three line is concur, so the next thing is that we have to prove DGH and is cyclic.
Okay.
Yeah, and just use the angle chase. Using the angle chase.
Okay.
Yeah. So the DNH is equal to the arc DF minus arc DE.
Okay. Arc DF minus arc DE. Yeah.
And divided to 2, and we need to prove that arc DF minus arc DE over 2 is equal to arc AM. Yeah, it kind of simple because you just need to use the angle chase, because arc the DF is arc the DF is 180 minus the angle FBD. It is the angle ABC, and the same with arc DE.
Yeah, you could just figure out what these angles are. Okay,
yeah.
So so I know Arjun just gave a proof that they concur. Did you have a different proof?
Yeah, I have a different proof.
Okay.
Yes. So if we call BC cut EF at N, so I gonna prove and L. Could you
hide it?
Draw LM.
Oh, LM.
No. LM intersect BC.
Okay. So the midpoint of BC.
Yeah. So we have that let's call it
P. Is P okay?
yeah, okay. So we have hold up the chat. Yeah, LP times LM is equal to LC square. And if we have N is collinear to L and G, so we have LG times Ln is equal to LC squared too. And so that on we just need to prove that MPGN is cyclic.
And it is,
Yeah.
because they're both right angles. Yeah. Or angle
yeah,
MPN
kind of.
is 90 and angle MGN is 90. So it's cyclic.
Yeah.
Okay. Let me
no,
think.
but
Oh no.
like,
We didn't have LN LGN is collinear. Yeah, and we gonna prove dP times dN is equal to dm times dg.
Okay.
Yeah,
Well,
but B C dN is minus 1.
Okay.
So but P is the midpoint of BC. So according to the Maclaurin theorem, we have that dB times dN is equal to dB times dC is equal to dg times dm.
All right. I'm going to start writing this out. So I don't think we need that this is cyclic right here, right? It's an interesting fact, but I don't think it's needed for the proof, right? So let me let me do this step by step. So let me check the chat for a sec. Sorry. You think our June's proof was simpler? Okay, I'm going to first start out by just writing out some of the stuff. Let me think, how do I start? Let BC intersect EF at N. Whoops, sorry. And then we want to show DGHN is cyclic, and that's sort of just an angle chase because okay, so first I'm going to prove that DGHN is cyclic, so that's the first step. And let's see. And then, so there's two steps. DGHN is cyclic and LG and N are collinear. And to show LG and N are collinear, Fung had a proof DHN equals D, DNH equals DKA equals DGA. Yeah, okay, so that's the simplest. Yeah.
Why
so
DNH DKA?
So I'll write it out in just a sec. So so DNH, that's 90 minus.
We have got it.
Do we have a nicer proof than Steve theorem for the intersection of three lines?
So because AK is perpendicular to EF, so I'll just label this point right here. Hold on just a sec. So DNH is yeah, I'll just, so DNH is 90 minus DRN.
No, no, DNH is equal to DKA. Yeah, that's what you
So yeah, I guess that would be the full proof.
I think that it doesn't give us our desired thing.
But that's DKA, which is MMLA. Sorry. DGA. So that means that DGHN is cyclic. Okay. And once we have that, now we want to show L, G, and N are collinear, right? So what was the argument? So Arjun, I think you had one, and I think Feng had a different one. BECF and AD.
Yeah, they concur. It is easy to prove by Seva's theorem.
Okay. Is that the best way to prove that L, G, and N are collinear? Because all we need is that L, G, and N are collinear, right?
Oh,
Like that's a simple
actually we don't need LG and N is collinear.
Oh really?
We just need NG is perpendicular to MG.
MG is perpendicular to NG.
Yeah.
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 Do this with it.
That is the MBGN is cyclic.
MBGN is so I think what we could just say is that okay, we want to show B, C, D, and N are in harmonic conjugation. That's why you try to show that A, C, B, E and A and AH concur. Okay, so and yeah, was the idea by Menelaus? I feel like there's got to be a simpler way to show that. It looks like a very
Actually not
like
AH, AD. It's AD.
AD, yeah. So B, C, D, and N are in harmonic conjugation. So yeah, how do you show? How do you? I guess so. Feng just wrote that they're in harmonic conjugation, but do you like? How do you prove that other than saying that BECF and AD are concurrent?
Okay.
But
So
one
let
way to
AD cut the X circle at another point.
Okay.
So yeah, we have that F, D, E, and that point. I don't know how to call it in English.
Harmonic, a harmonic quadrilateral.
Yeah, harmonic. Yeah. So if we project on D, so D, E, D, F, and D another is -1. Yeah. So project it on the line EF. So we have, yeah, and we let A project it on line BC.
Okay.
Yeah. Kind of simple.
But how does N get in that? So if I
But we should know that other tangency point from N to the X circle is on AD. How do we know that?
oh, is that pole and polar? Yeah, that's pole and polar. Okay.
No. Okay. So we just need that. Just let's call ID cut the X circle at another point. Let's call it T.
Yeah.
Yeah.
And then since n lies on the polar of A, then A lies on the polar of n. So ns is tangent, and so then we can project through S.
No. Oh yeah. We can project. No. We gonna D F S E is a harmonic. So we project on D. So DD is DN, DE, DS, and DF. Project it on the line EF. Let's call DS cut EF at another point.
Okay.
Yeah. Yeah. So we have EF DN is a harmonic.
Mm-hmm.
Yeah. So we let project A on the line BC. So we have BC DN is yeah.
Okay.
Yeah.
All right. I'll stick with this proof just because yeah, we spent a while on this problem, but I like it. So, whoops, sorry. I want to do a segment instead of a line. Okay. D, so Hakan, I'm just trying to see what Hakan was saying first. Project DTEF. Yeah, it was basically the same idea, I think, right? Yeah, Hakan basically said what Feng said. So let AD intersect EF in the X circle at T and S. All right. All right. And then so SD passes through A. So I'll just say DFSE is harmonic. Since AD and AE are tangent to the X circle. And I'll just leave it at that. And so the cross ratio FE DS is -1. And then we can project through D. And then, okay. So projecting through D onto EF. We then have FE NT is -1. Actually, I think I switched the letters. Let me, so that's FETN. Then this should be FESD. Yes, you're right. AF is tangent. All right. And then projecting through A onto BC. We then have BCDN is -1, so they're in harmonic conjugation. All right, I like that. And let me make some room here. Once we know that, GD is an angle bisector. So that means that angle DGN is 90. Just a moment while I do this. Okay, so GD passes through M, means that GD bisects angle BGC. And that means that angle DGN is 90, since BCD and N are in harmonic conjugation, and that means that angle DHN equals angle DGN equals 90, and that means that HT is perpendicular to EF. So some good teamwork. All right, I like it. So I will move on to the next problem. It's a fun solution. Did I make it full screen before? I don't think I did. Oh, well. Oh, this is an interesting one. So we have a scalene triangle ABC, an acute scalene triangle. We draw the orthocenter and the centroid. So let me first draw the orthocenter. What's going on here? I feel like that should have. All right, so that's the orthocenter. I'm going to call it H. So the circle with diameter AH cuts the circumcircle of BHC and A prime. Now that's actually the A Humpty point. So I'm just going to draw the medians for now. So I'm not sure how many of you have seen this before, but the point A prime, it's actually the perpendicular from A to HD. So this is nice. So G is the centroid. Whoops, sorry. Oh, really? It's trivial then? But basically, it's not hard to prove that A prime is really, it's not, so we can really drop the 3 perpendiculars to each of the medians. Oh, yeah, no, that does trivialize it. Okay, this problem was too easy. Okay. Yeah, all of them lie on the circle with, yeah, diameter HG. So, all right. I'm just going to quickly write it up and then move on to the next problem. Let's see. All right. Yeah, not all the viewers know all this stuff, so that's why I like writing it out. Although I know a lot of you already know this. All right. D, E, and F be the midpoints of BC, CA, and AB. So maybe I could call this. Let me give better names to these. Let HA be the foot of the perpendicular from H to AD. So then I claim that HA is a prime. We'll say, and similarly with HB and HC. And then by the HM theorem, so I think that's video 5, BH H prime A is cyclic. And also angle AHA, so that means that HA lies on the circle with diameter AH. And that means that HA is equal to A prime. And then similarly, HB equals B prime and HC equals C prime. So then it's easy to show that everything's cyclic. So angle HHAG is equal to angle HHBG is equal to angle HHCG. So that means that they're all cyclic. So HHA, HB, HCG is cyclic, and that solves it. I should actually change these all to primes, but A prime, B prime, C prime, G cyclic. All right. And I will just space this out a little bit and then move on to the next problem. Let's try this. There we go. I'm going to check the chat. See you, John. Oh, this problem was on that mock contest. Interesting. It's just bothering me that the word cyclic is so far away. How do I fix this. Does that do anything? Ah, this is so weird. There we go. All right, so I will move on to the next one. So B is a point on the segment AC. All right, I'll rename this point C. We want circles with diameters. Oh, whoops, that didn't work. We want circles with diameters AB, BC, and AC. All right, so I will do a bunch of midpoints here. Might as well draw the whole circle. Yeah, AB, BC, and AC. All right, so they're tangent, mutually tangent. The line through B cuts the, so T3 is the big circle. So it cuts T3 at points P and Q. And the circles at R and S. Okay, so I'm going to do some renaming here. So this is P, this is Q. Yeah, this doesn't look like a hard problem. If we finish early, maybe I'll try to find more problems. This is R, and this is S, and we want to show that PR is equal to QS. So really, that's just showing they have the same, saying that they have the same power with respect to the circle. All right, so how do we show R and S have the same power? Well, maybe it's just like we could show RF squared. I guess we just want to show FR is equal to FS. Right? If we can show FR equals FS, that does it. And is that easy? So if we drop a perpendicular from F to PQ, it bisects PQ. And then could we show that point has the same power with respect to both circles? If we can show that, that would solve it. Yeah. Hold on just a
I
sec.
think it's useful to draw AR and CS.
AR and CS. All right.
Yeah.
So yeah, FG, G is the midpoint of PQ. So FG is perpendicular to it. And I will draw AR and CS. Oh, and then I think that solves it. Or does it? Because G is the midpoint. So I think, well, AR plus FG is CS, I think. Actually, Yeah, is it obvious from that point then that Fs is equal to Fr? Because
Yeah, it's obvious from similarities, ratios of lengths, Bg over GS and Vg over Gr. We can calculate them in terms of AC, segments in AC.
Okay, so let me start writing it up. So let D, E, and F be the centers of T1, T2, and T3. Let G be the midpoint of PQ. And that implies that FG is perpendicular to PQ. And that means that, so yeah, now I'll just do the right angles. So angle BSC equals angle ARD equals 90. So that means FG is parallel to AR is parallel to CQ. Or this should be ARB. And then that means that BG over BS is BF over BC, and BG over BR is BF over, wait a sec. So I wanted to show that or I guess we want to show RG is equal to SG. So yeah, that that would follow from that. So so BF over FC, or maybe I should say BF over FC is BG over GS. And BF over FA is equal to BG over GR. Oh, there's a way just to use congruence. And then, so since FA equals FC, then we know that GS equals GR. And that means that FS equals FR. And then, well, I actually, now once we know GS is GR, then PR equals QS. So, Daniel from Iran, you just wrote that we can use simple congruence. So is there, so yeah, which triangles are congruent?
Hi.
Is it I guess we want to show FSQ is congruent to FRP. Is that what you're thinking? That's all right. Yeah, you can type it in the chat if yeah, you think of it later. So I will move on to the next problem. I think this is good for now. All right. So let's check out the next one. And we still have an hour and a half left, so there's a good chance we might finish early. This problem looks a little bit trickier, at least. So we have a point outside of a circle, and so PA is one of the tangents. So I'm gonna do it like this. I am going to call this A. But let me maximize. I keep forgetting to maximize stuff. And this, we will call it O. And then I will draw the tangent at A, and I will put a point P on it. So PA is tangent, and another line passes through, oh, whoops, let me rename it. So that's P, and okay, so this is B and this is C. I'm going to hide some stuff later. D is the reflection of P, the reflection of B with respect to P. All right. So, all right. So this is, hello? Oh, hello? Sorry.
Nhưng mà nó con mang tên con nó kêu
Oh, I'm sorry, Fung. I think there's some noise in the background, right?
Oh, okay. I'm sorry.
Oh, it's all right. No worries. So then we draw the circumcircles of DAC and PAB, and they meet at E, and EB intersects omega 1 at F. So what is omega 1? That's the circumcircle of DA, so that's the big circle, okay? And then we want to show CF is equal to AB. All right. So yeah, this one feels like there's just some congruent triangle somewhere. All right. That line does not pass through O, so I'm going to move things a little bit. Just okay. So PA is tangent. But yeah, let me not, because right now it looks kind of like, yeah, I don't want to make it look like it passed through O. All right. All right. I think that's a good enough diagram. We want to show CF is equal to AB. Interesting. Yeah, so it's got, the only way I can think is congruent triangles somewhere, right? So OC, let's see, OC is equal to OA, is equal to OB, and we want to show AB is equal to CF. I wonder if angle OCF plus angle OAB is 180. Let me check that. So it's just a guess. Let me check the chat. does the reflection of A across P lie on the circle? Let's try it out. Yes. Let's see, is that obvious? Is that just an angle chase? Because yeah, that would mean, I think it's just an angle chase, because then this would be a parallelogram, and that would mean this angle is equal to,
Yeah, it is obvious because PA square is equal to BP times BC is equal to PD times BC.
I was actually thinking about it a different way, but it's, you could, so but that works too, because yeah, PA squared is PB times PC, and so yeah, you can do it by power of a point or angle chase, so both of those work. And let's see, is A prime F parallel to CD? It kind of looks like it, right? I'm not sure. Yeah, it looks like A prime F is parallel. Yeah, and that would solve it pretty much. So let me delete this line right here. Because if we can show they're parallel, then we have CF is A prime D is AB, because it's a parallelogram. So is that just a simple angle chase? Oh, what?
Angle chasing. It's called Rimes theorem.
Rimes theorem. So basically, so basically AABC is cyclic. So if you, since yeah, okay. EBP is EAP is EAA prime is EFA. Yeah, this is too easy. So yeah, I think we're gonna get through all of them, and then I will look for some more problems. Maybe we could do APMO after this.
We can do mock.
We could do what? A mock? Or which contest? IMOC?
Yeah.
Okay. Yeah. So yeah, there's still a few more good problems on that, I think, that I haven't done yet. So I could try that out after this. But so let A prime be the reflection of A over P. So that means that A prime D AB is a parallelogram. So that's since AP equals A prime P and BP equals PD. Oops. What went wrong here? Oh, I got to add this. And then we can show that A prime lies on the circle through DACF, because that is just an angle chase, because we can calculate angle DA prime A. So we have DA prime A is equal to angle A prime AB, which is angle A prime CB. Or ACB, which is ACD. So that means A prime DAC is cyclic. All right. And whoops. Add that. And then I can use the angle chase from the chat to show that A prime F is parallel. Hold on a second. So where's the chat? Let me pull up the chat. We have yeah, it's hard to find really difficult contests. So, but yeah, I'll check out IMOC right after this. So let me check that out. EBP is EAP is EAA prime is EFA prime. So that means that CD is parallel to AF. And that means that CF equals AD prime equals AB. All right, so I will move on to the very last problem. Does this make sense to everyone? All right. And then after this, we'll check out some more problems. Or maybe there's a couple problems that we still haven't solved that I know of that we